Welcome back. The objective of this video is to go through two examples. The first example is just looking at present value with a series of different cash flow, and the second one is a more challenging exercise finding the interest rate. Okay, so for this example, you can see the cash flow is a little bit different at each period. So we started with 40 in the first year, 30 in the second, third, 20 in the fourth, and 50 and 30 in the fifth year. Okay, but the way we're going to do this, we're going to break it up to make it very simple for us to find out. So what I have essentially done is I can rewrite this entire thing as a 5-year $30 annuity if we add $10 in the first period and minus $10 in the fourth period. So the way I set it up like this make it very simple, because now we can apply the table or the equation to solve for the mass. So for this annuity, we just write it as 30 bracket find P given A, I and N. And using the interest rate table, I have a factor of 4.2124. And so we get our present value of the annuity to be 126.372. Okay, the next thing I do is find the present value of the $10 in year 1 and 4. So in year 1, I look at my find present value given future value, I and N, and my factor was 0.9434. So therefore the value of the $10 in year 1 was 9.434. And similarly, the present value at year 10 was 0.7921. So my present value at year 0 of the $10 in year 4 was 7.921. Once I have done find the present value of this, and this, then all I have to do now is just add them up. So we add the annuity because that has the inflow. We add the extra $10, but we minus the $10 in year 4 because we have $20 here. Okay. Once we have done that, we just add them all together and minus this value. We get the present value at year 0 to be 127.885. Okay. So that was an example using different cash flow, and once you have broke it up, it's actually not too difficult. The second example is a little bit trickier. We are now dealing with interest rate. Okay, so here is a slightly more complicated example where we have a deferred annuity as well as a single cash flow. Okay, and the key thing to this is to set it up properly so that you understand what is going on. And I'll be doing this through equation as well as using the table, and essentially set up the question correctly, and then the rest of the process is exactly the same. So for equation, you actually can't solve this like we have solved for n, because there is an r here and there's an r square here, so it's extremely difficult trying to solve it by hand. So we'll be doing some guessing and then some linear interpolation. Okay, so what I've done here is discounted the first 100 back to 0, and then I'm going to discount the annuity, these three annuity at time 2, because it's always one period before the first annuity payment, back to time 0. So here is how I've written. So the present value of this annuity can be written as 100 divided by 1 plus r plus PV2, which is the present value of the annuity at time 2, divided by 1 plus r squared. And the present value at time 2 is just simply the annuity formula. So I just rewrite this as A, which is 20 times 1 minus 1 plus r to the minus n, which is 3 divided by r. Okay, so if I substitute this into the first equation here, then we can rewrite this entire thing as such that the present value of this annuity equals 100 divided by 1 plus r plus 20 bracket 1 minus 1 plus r to the minus 3 over r times 1 plus r squared. Okay, so once we get up this point, all we're going to do is try two interest rate, and hopefully one interest rate will be higher than the 140.5 and one to be lower than the 140.5 that we're looking for. Okay, so we're going to try 6%, and all I do is put 6% into here, 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 and here, and we get the present value to be 141.92, which is higher. So if the present value is too high, it means our interest rate is too low, because the two things are inversely related to each other. So what we're going to do now, to reduce the present value, we will increase the interest rate. Okay, so we increase it to 7%. We find that if we were to put 7% into here, 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 and here, we get the present value to be 139.30, which is good, because now we know our present value of 140.5 is somewhere in between 6 and 7. So now with these two values, we're going to linear interpolate to find what the actual interest rate is. Okay, so this is how we do our linear interpolation. We just simply write the gradient formula on either side. 7 minus 6 over 139.3 minus 141.92 equals x, which is the interest rate, minus 6 over 140.5 minus 141.92. Okay, and if we were to rearrange and solve for that, as I have shown here, okay, you can see that the left hand side, if I just do that calculation previously shown, you get minus 0.3817, and on the left hand side I just left that as it is. So the next thing I did was I took this thing to the other side, so I times it like that, and then I took the 6 to the other side, added on, and then we did all that, we get our x to be 6.542. So our interest rate is 6.542. Okay, and if you were to sub this 6.542 back into the initial equation here, you will get the present value to be 140.5, which is what we were looking for. Okay, so now I'm going to quickly go through the exact same example if you were using the interest rate table method. Okay, so the first thing we do is, once again, we have to set up our present value. So we got to go, the present value have to equal the $100 discounted back to time 0 plus the present value at time 2 of the annuity discounted back to time 0. So here discounted back to 0 and here discounted back to 0. And we know the present value at 2 is just simply an annuity, which is a time find present value given annuity I and n. Okay, so all we do is sum up this annuity to here, discount it back, and discount this back, like we have done with the equation method. Okay, so next thing we do, just combine the two, because this is a multiplication. All we do is put this in here and go a, which is 20, times this discount factor times the other discount factor. Okay, so we end up with present value equal 100 bracket find present value given f, I, and n, plus annuity times present value find present value given annuity I and n, times find present value given f, I, and n. Okay, now if we do that, the next step will be exactly the same as when we do the equation. We guess a interest rate, and hopefully it will work out. So as I've done this with the equation, I will try 6 first. So I go to my interest rate table, look up the discount factor for this, this, and this based on 6%, work out my final answer to be 141.92. Then I repeat the same thing using 7%. I will get this answer to be 139.3, okay, as we would using the equation method. And then all we have to do now is linear interpolate, just like I have shown, just like this, okay, and we will work out the interest rate to be 6.542, okay, as we have previously got. Okay, so essentially for both method, the only difference is this line here. Okay, whether you want to set it up like this, or set it up like, or you want to set it up like that. Once you have got that, you just have to try different values and linear interpolate. Okay, thank you.